Hey everybody, this is Miss Peachy from your WCA physical science class, and I'm doing this short video tutorial to kind of give you some instructions on what you need to do for your upcoming portfolio here. I'm just going to scooch myself over a little bit to the side just so you can see that we are looking at the lab thermal energy transfer. And I'm going to also switch to the calendar view for a moment so you can kind of see what's supposed to be on your calendar for the week. So you have actually two portfolios back to back this week. You've got the Project Solar Cooker and the Lab Thermal Energy Transfer. Well, we are going to drop the Project Solar Cooker. It's kind of a cool project, doesn't work real well in the winter in Wisconsin necessarily. And having two back to back on the same week is kind of a lot, I think, for anybody to try to do since these portfolios tend to be kind of long all by themselves. So we are just going to focus on the lab thermal energy transfer. This is the one you're going to do, so you don't have two things to do this week, you just have one. I'm switching to my website here. I actually need to load that up for you. And hopefully you're familiar with this by this time in the school year, but if you're not, you're going to click on more if you need to. Otherwise, if your screen resolution is bigger, it'll all be at the top of the screen. Go to Physical Science, Semester B. Scroll on down here to Portfolios, and you will see Project Solar Cooker is dropped. But if you go back down to Thermal Energy Transfer, you'll see the student guide here, and this video, which currently says coming soon, is being made right now. So that'll be posted there as well. So the student guide that I have posted on my website is the student guide that you will need to complete. As per the last portfolio, this is kind of an alternate document that I created, put together a lab report kind of format with your data. So don't just turn the data sheet into me. This is what you need to complete and submit to me. Okay, let me open that up here for you. I'm going to bring it up on my screen. So as you can see here, it kind of brings together that lab report format that we had from first semester. You have to put the purpose of the lab. So for the purpose, you are going to be discussing what scientific principles you're supposed to be learning about in this lab here. So what are you trying to discover? The hypothesis or hypotheses, you are addressing the variables that you're testing, and you are going to determine what you think the outcome to those variables are going to be. So you're explaining what you think is going to happen and why you think it's going to happen. So don't just give me that what portion, make sure you give me the why. Try to use some science to back up what it is that you are trying to say. Okay, so maybe use the first law of thermodynamics here, right? That's going to be a helpful scientific law to help back up your hypothesis. Question 3 is where I see a lot of struggle with students, the methods that you're using. So you are going to make sure that you're giving me enough detail without giving me too much, but err on the side of caution and give me more if necessary. Don't just tell me that you're using the Edgenuity app. Explain the steps that are used virtually in order to be able to get the information. So explain the experimental setup a little bit and exactly kind of what you're doing to arrive at the data that you're collecting. Okay, so do this in a small paraphrasing kind of summary where you give us the gist of what you're doing. Again, don't give me step-by-step directions, but give me more than just a sentence or so. You probably need a good 3 to 4 sentences here to be able to adequately describe your methods. Now we have data collection, and we also have calculations and analysis. So these are the data that you're going to be taking. Table A is the effective mass or material type on thermal energy transfer. So your initial temperature, final temperature, and delta T refers to change in temperature. So you take final minus initial to get your delta T. Okay, you're going to do this for water, for wet sand, and for dry sand. And then you need to give me some answers to some broad questions. Which sample will heat up faster? You should do this prior to actually testing. So this is more of like your part of your hypothesis, right? So you think the 100 gram, the 200 gram, or do you think there'll be no difference, and explain your reasoning? It says circle one here. You can highlight these. That's fine because circling's a little hard to do online. Same thing for this one. Which samples do you think will heat up faster? Water, wet sand, or dry sand? No difference, and explain your reasoning. And again, this should really help guide you in your making of that hypothesis. So this is kind of what you're looking at in that hypothetical portion. Table B, you're going to calculate something called specific heat. So specific heat can be calculated taking the specific heat of water times the mass of water times the change in temperature of water divided by the mass of the metal times the change in temperature of the metal. So this is the formula that you're going to need to use. It looks complicated, but it's not that difficult. So specific heat of water. Specific heat of water is given for each one of these. It's 4.18 joules per gram Celsius degrees. Okay? You're trying to figure out specific heat of metal here. You don't know what that is. But you do know the mass of the metal in grams, the mass of the water in grams, the initial temperature of the metal in degrees Celsius, and the initial temperature of the water in degrees Celsius. Okay, the temperature at which they came to a state of equilibrium, right? So delta T for the water, you take the equilibrium temperature, which is this, and minus the initial temperature to give you delta, or to give you delta T here. So basically, they both came to the final temperature, the same final temperature, which we call TEQ. That means the temperature of equilibrium. They both came to the same temperature there. So to get the final, or the delta T, which means change in, delta refers to change in, we take TEQ for water minus T sub I for water. And to get the change in temperature for metal, we take the TEQ for the metal, which is the same as the water, and we subtract the T sub I for the metal. That gives us delta C, okay? Then we use this formula here. So you're going to take that 4.18 times the mass of the water times delta T of the water, get that total. And then take for the bottom portion, you take the mass of the metal times the change in temperature of the metal. Once you have the top portion and the bottom portion, you can take the top portion and divide it by the bottom portion to give you the C of the metal, which is the specific heat of the metal. If you feel like this is like really hard for you, this part here with all the calculations, please send me a webmail and we can meet together in my virtual classroom and kind of go over some examples, okay? So if you're feeling like this part is a little bit challenging and you're not quite sure you understand the math part of it, you feel free to send me a message and we can kind of meet together to go over some examples. Now you're going to compare the specific heat of the metal that you calculated to the actual specific heat of the metal here, right? And you're going to be able to take this table and figure out your percent error. So if you've got the aluminum, this is what it should be, and this is what you calculated. So you have to figure out the percent error for this. Now to figure out your percent error, you're going to take one second. Huh, that's weird. Okay. Okay, you'll take the measured value minus this value here, then divide it by this value, 0.9, And then whatever you get, multiply by 100 to get your percent error. Okay? So let me write this in here for you. I thought I had it already written in here, which is what I was kind of looking for, but I'll just insert, I'll do a comment here and you guys can all see it on the video, okay? So you take your measured value minus the table value. So that's that 0.9 here. Okay, so do that first. Whatever that, I'll put that in parentheses. Okay, so you remember that you're going to do that first and come up with a difference there. Whatever that is, divide it by the measured value again, or nope, divide it by the table value again. Okay, come up with a total there. Then take that whole thing and multiply by 100. Okay, and that gives us our percent error. You can kind of see that there. Measured value divided minus table value, get the difference, divide it by the table value, and multiply by 100. And that should give you your percent error. Okay. When you're all done with those calculations, you don't have any graphs to do for this portfolio. Well, you're probably really excited about that. Then you just need to finish up your questions here. So you're going to get your key results, summary of the key findings, qualitative and quantitative data, what do the results indicate. You do not have graphs, so you can just put not applicable here, NA. Any problems you had, reflect back on your hypothesis, find data that supports your hypothesis. Actually pull out examples of data here that support your claim. Don't just say, my data supported my claim. Well, give me some examples of how that is true. So pulling out numbers from your data tables helps there. Okay. And then give some suggestions for improvement for the experiment. If you were to improve this experiment, what would it be? Okay. Once you're done with all that, you just save it and submit it to me through the Dropbox. That is it. Again, if you have questions on that calculations portion, hopefully it's pretty straightforward, but I know sometimes when you put in symbols like delta, you're like, what? Why are you putting in this crazy old triangle in the middle of an equation? And it gets a little confusing. So if that's the case for you, you can completely get help on that part. Just send me a webmail and I will meet with you in my virtual classroom and we can go over how to do that with some real data. Okay? But come to me with all your data tables done at that point. Hopefully that helps. If you have any questions or concerns, let me know. Otherwise, have a fabulous day.